Madagascar is the fourth largest island in the world. Over 160 million years ago, it separated from the African continent. In this isolated environment, incredibly diverse plant and animal life thrived and evolved like nowhere else on the planet. Explorers, scientists, and researchers have marveled at this tropical paradise for centuries. Alarmingly, many of the unique creatures and vegetation now face imminent extinction. Most of the original rainforest that was home to these rare plants and animals is already gone. What remains is under daily assault. The growing population must choose between preserving natural habitats and feeding themselves. Conservation versus survival. In an effort to achieve both, people on opposite sides of the world are working together.
Major funding for this program was provided by the Theodore F. and Claire M. Hubbard Family Foundation, with additional support by From the Top, a national public radio program showcasing the musical talents of young people, and Huntel Communications Incorporated.
The island of Madagascar is home to an extremely rich variety of plants and animals. Approximately 80% of those plants and 100% of the native primates, like the lemur, are unique or endemic, meaning they are found nowhere else in the world. Madagascar, located off the southeast coast of Africa, is a little smaller than Texas. A very small area in physical size, but an extremely critical one. In 2005, it was estimated that as little as 10% of the original forested area remain. With 90% gone, what remains is only 15 to 19,000 square miles, an area roughly 2.5 times the size of New Jersey. This destruction impacts humans everywhere. Rainforests contain over half of all living species. Because of the dramatic threats to the survival of these plants and animals, scientists consider Madagascar to be a biodiversity hotspot. Biodiversity refers to the variety of plant and animal life in a particular habitat. A biodiversity hotspot is one of the most endangered environments in the world. Hotspots like Madagascar are areas where immediate action must be taken to preserve the remaining plants and animals from extinction. Already lost with the destruction of Madagascar's forests are creatures such as the giant indri, a lemur that was the size of a gorilla. Researchers have documented over 19 lemur species that are now extinct. Other creatures such as the elephant bird, which is thought to have been the largest bird in the world, are now only museum displays. Dedicated scientists and conservationists are working to preserve the country's surviving plants and animals. One leader in these efforts on the island is the Henry Doorly Zoo. The Omaha, Nebraska Zoo operates a long-term conservation project in Madagascar. The goal is to preserve a variety of species from chameleons to geckos, turtles and tortoises, to lemurs and orchids.
This process has been a learning experience.
The zoo's Madagascar Biodiversity and Biogeography project is the personal vision of Dr. Ed Lewis.
There's so much biodiversity in this country that it would be impossible to just go out and just say, we're going to protect this site, this site. There's got to be a plan.
Lewis and his team work in collaboration with the Malagasy government and non-governmental organizations, referred to as NGOs. In addition, students and faculty from the university in Madagascar's capital of Antananarivo, commonly called Tana, play critical roles in the project. Together, they are using scientific methods to collect and analyze data on individual species down to the molecular genetic level. This research will help Madagascar create a practical conservation plan.
It's designed to basically empower the Malagasy. We bring our expertise, experts in whatever taxa that we're working with at the time, to train the students, to enable them to be able, basically to become leaders of tomorrow. We are not going to be the ones, I'm not going to come over here and save the day and save Madagascar. We're basically going to hopefully give them a helping hand. They're going to have to be the people to do it. It's their country, it's their future.
The genetic research the scientists are doing will ultimately help the government of Madagascar manage animal populations and habitats. In the process, they are identifying new species of animals and plants. They are also preserving genetic material. This can help ensure that examples of rare, endemic species can exist in the future.
We have a job to do. We have to basically protect what we have now for the future. It's for our kids, our grandkids.
In terms of biological diversity, Madagascar is one of the richest countries on Earth. And what occurs there, much of it doesn't occur anywhere else. So if it's lost in Madagascar, it's lost to us all. So conservation there is an imperative.
In recent years, the Malagasy government has officially embraced conservation. Since 1993, the Malagasy Constitution has put conservation goals into written policy. So far, only a small percentage of the remaining forested areas are considered officially protected land. In 2003, Madagascar's president took unprecedented action. He committed to tripling the protected areas while asking for $50 million in international assistance to do so. By June of 2005, almost all of the money had been pledged.
They want to multiply by 3 times the surface of the air protected Madagascar. And I think that's great and hopeful.
Committed students like Tahina are essential to the future of Madagascar. Ultimately, it is up to the Malagasy people to apply conservation practices. With this in mind, the Henry Doorly Zoo's efforts extend beyond scientific research to include education. Empowering the people with knowledge and skills is an important part of the project. Local communities must understand the value of their country's unique biodiversity. But conservation efforts face difficult hurdles because of the extreme poverty that exists in Madagascar. This is one of the poorest countries in the world.
Clean drinking water and rice on a daily basis is what is on the minds of these people. Conservation is a luxury. They can't afford to think about conservation in the future.
They hunt and they use the forest products to stay alive, and I think it's very important for them. But their practice destroy the forests.
People first migrated to the islands some 2,000 years ago. Initially, they came from Malaysia, and later from Africa and other countries. The people are shy and gracious, with great respect for family and ancestors. They are deeply connected to the land by their traditions and their farming practices. Rice cultivation came with the Asians and is the staple of the people's diet. They consume more rice per person than any other country. Traditions of raising cattle came from Africa. Both farming practices are very destructive to the country's precious natural habitats. But the destruction is caused by very poor people trying to survive.
Madagascar is very vulnerable. They have many people to feed on a minimal amount of arable land. They are forced in desperation to burn off parts of the forest for cropland that usually is productive only a few years, and then it's abandoned.
The traditional method of clearing forested land for agriculture is slash and burn. It is called tavi in Malagasy. After burning and removing the trees, rice is planted. The rice farming strips the nutrients from the earth after a few short years. Then new areas must be cleared for more rice cultivation. The precious and shallow topsoil erodes away, washing into streams and rivers. The depleted areas are useless and are often abandoned. Intensifying this destructive cycle, Madagascar's population of nearly 18 million is expected to double by the year 2025. Nearly half of the people cannot read or write. Many Malagasy children do not attend school.
We need conservation, but the problem is only educated people are able to understand it. But most of the people don't care about it because they are struggling with poor living conditions. More education for the people is really needed.
One of the key components of the Henry Dooley Zoo's project is the work that Dr. Lewis and his group are doing with lemurs. The lemur has been an object of fascination since man first set foot on the island. The exotic animals are one of the earliest forms of primates and are found only in Madagascar. They still exist today because Madagascar broke away from the landmass that created the African and Asian continents approximately 160 million years ago. Scientists once thought that these unique mammals evolved on the island after the separation. But fairly recent discoveries indicate that lemur ancestors may have crossed the Mozambique Channel from Africa on logs and debris. However they arrived, the lemurs flourished in Madagascar, but nowhere else. There were no large predators, including humans, to threaten them. They found their own Garden of Eden in this island paradise. Bill Constant is the Director of Conservation and Science for the Houston Zoo and is a seasoned wildlife conservation veteran. He is also a main contributor to the field guides on the lemurs of Madagascar that have been created by Conservation International, an organization respected for its conservation innovations.
The island of Madagascar is located not far south of the equator, so the climate there is tropical or subtropical. Rainfall amounts vary considerably across the island, from 12 inches to more than 140 inches, or from 1 foot to over 12 feet. Because of the diversity of rainfall and topography across the island, you have a wide variety of habitat types ranging from desert to grassland to lush tropical forest, and you find lemurs in all of them. At least 70 different species of lemurs are known from Madagascar. That's more primates than in any other country in the world except for Brazil. In Madagascar, these range from tiny 2-ounce mouse lemurs to the 20-pound indri. Also throughout the island, you have habitat destruction, largely through slash and burn agriculture. That's been particularly harmful to habitats in the Central Highlands and the eastern coastal rainforests.
Researchers have identified nearly 20 lemur species that are now extinct. They were probably large, slow-moving, and easy prey for hungry humans. Today, being hunted is the second biggest danger to lemurs after the loss of habitat. To preserve the lemurs, their habitats must be protected. Saving these habitats will in turn preserve many of the species.
For every one plant species that goes extinct, 10 to 30 non-plant species go extinct with it, and that includes animals, insects, and microbes. That's a very scary thought. It has incredible impact on biodiversity.
Lemurs have become a very visible symbol for conservation in Madagascar, much like the giant panda in China or the bald eagle in the United States. Efforts to save lemurs have to focus on protecting the habitat that they live in. And when you do that, you're also preserving habitat for a variety of other creatures, in essence, for all the biological diversity that's found in Madagascar.
Dr. Lewis first went to Madagascar in 1998 because of his interest in amphibians and reptiles. He soon found a new focus.
Instead of doing little discrete projects at one side or the other, I really wanted to create something that would have a huge impact on protecting the biodiversity and the management of these protected areas and establishing new areas of protection.
The conservation crisis in Madagascar gave Dr. Lewis the opportunity to create this new multifaceted project. His vision is having a tremendous impact.
Without somebody who's willing to go in and spend time in situ, in the field, on the ground, like Ed is, and an institution that's willing to support him, you don't accomplish anything.
Until recently, information on lemurs was collected largely by observation. The Henry Doorly Zoo is conducting more systematic examinations and collecting more genetic information from more lemurs than ever before. This research allows scientists to better understand the history and evolution of lemur species. The collection of genetic material is critical in identifying the location ranges of various lemurs. This is one of the key issues being addressed by the research of Dr. Lewis and the Henry Doorly Zoo. These genetic surveys also help identify which remaining forests have the greatest biodiversity. All this data helps Malagasy authorities make informed decisions about prioritizing habitats to be protected. The project helps focus conservation efforts and channel limited funds to where they will have the greatest impact. Collecting so much information from so many places presents real challenges. The fieldwork is very physical, often requiring difficult travel to remote locations.
Working in the field is very hard work. You have to sacrifice quite a bit. The roads are historically terrible. Depending on where you're at, they can be impossible to get through during the rainy season. Cyclones, flash floods, bad roads, no bridges. Definitely, you have to be very persistent about, wanting and getting to the site. That's, I guess, part of the charm in many ways.
When the team reaches a field site, they begin looking for lemurs. A precision air rifle is used to tranquilize the animals.
We immobilize them, we hit them basically with a dart in the thigh region as softly as we can. Usually about 2 to 5 minutes later, the animal becomes sedated, can no longer hold himself up in the trees, and it falls. And then we basically try to catch the animal on net so that it doesn't hit the ground.
The Malagasy team can locate and dart a lemur with great accuracy and speed. Their skills contribute immensely to the overall success of the project.
This project wouldn't be possible without the guides. Their knowledge of the species, the knowledge of the forest itself, just lends to the ability for us to find the animals and get the samples. Their compassion for what they're doing and their work ethic is amazing.
The sedated animal is taken to a temporary field lab for an exam. The tranquilizer used also includes a painkiller. The lemur feels no discomfort and is generally unaware of what is happening. The sleepy animal cannot blink, so it has an odd, glassy-eyed look. A tear lubricant is applied to the lemur's eyes to prevent cornea damage while it is sedated. The field collection efforts take the team to locations all over Madagascar. They are cataloging data on many different species of lemurs. Other aspects of the field exam include weighing and measuring the animal. Blood and tissue samples are collected from the lemur. Data on the teeth is also recorded.
Nice, clean teeth. I mean, she's very young.
This overall exam sizes up the lemur's general health and approximate age. To identify each collected animal in the future, the team has adapted the same technology used for identifying pets in many countries.
We implant a pit tag or a microchip between the shoulder blades of each of the animals that we dart. And if we are back in the forest darting that same species and do hit one of these animals again, we can wave the wand over it and know that we have that animal in our database.
Ultimately, scientists will be able to obtain a specific lemur's collected data by the pit tag number.
The information that Ed Lewis, the team from the Henry Dorley Zoo, and their Malagasy colleagues are collecting is incredibly important to conservation. This information is going to be analyzed for decades to come. It's telling us where lemurs are found, what types of lemurs are found where, and what their conservation status is.
Before the animal is released, a small section of the lemur's tail is shaved. Once released, the guides can tell that this particular lemur has already been darted as they look for more animals. When the exam is completed, the crew waits for the sedation to be completely worn off. The lemur must be alert before it is released. When each animal is captured, its precise location is recorded using GPS, or Global Positioning Satellite Coordinates. Using the GPS data, scientists can analyze lemur population patterns. It also gives the team precise coordinates for the release. The lemur is back in familiar territory and can easily rejoin its family group. As of June 2006, samples for nearly 2,100 lemurs had been collected, and less than 1/3 of the proposed 200 sites had been visited. Because many lemurs are nocturnal, they have not been studied much in the past. Unlike previous efforts, the zoo's team frequently searches for lemurs at night. As a result, their ability to identify new species has been dramatic.
I think that's the unique part of our project. We're looking at really a large number of animals, and that's allowing us to detect differences. And in fact, a lot of times we haven't even realized that we had a new species or there was a difference until we ran the molecular genetics, and then we went, oh, that's interesting, and went back and looked at the photographs that we've taken and said, oh my goodness, they are different.
This project in the scientific and conservation communities is really a very big deal. In addition to very systematically and methodically mapping Madagascar, Ed and his team are discovering new species.
We're naming new species of leopard lemur, which are the sportive lemurs, the microcebus, which are the mouse lemurs, and we have a lot more in store. We have a lot of surprises. I think it's going to really shock people when they realize that, you know, there's that many species of lemurs here in Madagascar.
The work results in creating a catalog of data and genetic samples. The country of Madagascar can use the information to help protect the lemurs and their habitats. The Madagascar Biodiversity and Biogeography Project is just one example of the zoo's commitment to conservation and education.
Conservation work is very important, and it's great to see a zoo put as much finances and effort and infrastructure in a project like this.
That has become a main part of the Zoo World's mission, not just Omaha's, but the Zoo World's mission today, is to support in situ, in the field, conservation that actually has an impact on preservation of endangered and threatened species in the wild, in their habitat.
Dr. Lee Simmons is the director of the Henry Doorly Zoo. He and his staff are passionate about protecting endangered creatures and habitats. Simmons' visionary thinking has made this one of the nation's top zoos. Visitors experience habitats from around the world firsthand. These exhibits educate the public about the enormous benefits of wildlife conservation. The main focus of the conservation effort in Madagascar is protecting the lemurs. To accomplish this, it is critical to preserve their diverse habitats, habitats that are rich with biodiversity. The dense forests are also home to a host of unusual plants. Many of these, like the lemurs, are endemic, are found only in Madagascar. Another Henry Doorly Zoo expert working in Madagascar is Marge Fromm.
A place like Madagascar represents one of these last microcosms of possibilities because so many of their plants haven't even been classified yet. Any botanical expedition that goes over there just about finds some new plant species. That's phenomenal in the 21st century.
The complex relationships between plants, animals, and other organisms create more challenges for conservationists. This interrelatedness of species makes the removal of trees from the forest even more devastating to the ecosystem. The zoo's curator of horticulture, Terry Govea, has been to Madagascar many times.
Every piece is important, and it's all connected. The relationship between the fungus, the tree, the entire ecosystem is all interdependent. And you start taking pieces of that away, and it has a ripple effect on the whole ecosystem.
The interdependence is terribly important for any species. Biodiversity represents all the living organisms. The bamboo lemurs depend upon bamboo to live. Bamboo lives as understory plant of the forest. The trees provide the home for the orchids. The orchids provide pollen and nectar for insects. It just goes on and on and on.
Studying the island's orchids is another collaborative part of the zoo's Madagascar Biodiversity and Biogeography project. There are over 1,000 documented species of orchids in the country. 80% of those plants are found only in Madagascar. Like the Lemur project, the orchid research directly involves and trains Malagasy people who will hopefully continue and expand conservation efforts. The ultimate goal is saving endangered orchid species. The concept is to take seeds from Madagascar, germinate them in a lab in Omaha, and reintroduce the plants back to where they came from. Fromm and Gouveia have worked in endangered habitats around the world, but all their experience left them unprepared for what they would find in Madagascar.
In 2000, Terry and I went to the eastern rainforest region of Madagascar in an area where nobody in human memory knows of any scientists that had done any work on orchids.
It was emotional for me because here we are on this mission to do a conservation project in this forest, and as we approached the forest, I saw flames. I saw currently, right there in front of me, forest being burned down. But the forest itself was just beautiful. It's so beautiful.
The conservation process begins with the collection of seeds in Madagascar.
They are problematic in a number of ways. First of all, they are so tiny, most people can't even see them clearly. They're smaller than the finest grains of dust.
Orchid seeds pods can hold up to 50,000 seeds, but only half a dozen may germinate in the wild.
That's just the way of nature. There are just too many things that want to eat those seeds or attack those seeds for their existence. But in the lab, we can produce many hundreds of plants from a small sample of seeds. That's a huge advantage for conservation and further research and education.
Very specific field biology procedures are used.
We would try to identify the genus of that particular orchid. We would document the date, of course, the altitude, the habitat, was it found on a specific tree, any information that may be a variable in that plant's growth, that culture.
Orchid seeds are collected in Madagascar. Some went to the university in Tana for research, while others were taken to the Henry Doorly Zoo. Seeds that came to Omaha were earmarked for germination or deep frozen for long-term storage. The freezing process called cryopreservation uses liquid nitrogen. The seeds are frozen at extreme temperatures, down to minus 196 degrees centigrade, or 321 degrees below zero Fahrenheit. Cryopreservation gives conservation science the ability to save a species, even if there's only a tiny bit of seed. That seed can be stored for decades. At some future time, it can be thawed out, germinated, and reintroduced back into the mother plant's original habitat. The cryopreservation worked very well. In tests, the researchers have successfully started plants from seeds that were frozen.
They produced many thousands of little orchids from those seeds, so we know it's possible.
Back in the plant laboratory, the scientists work with the seeds set aside for germination. They have developed successful procedures for getting the orchids to grow. The tiny seeds are placed in a series of sterile cultures. These glass vials contain all of the nutrients the little orchids need. From the Henry Doherty Zoo's plant scientist successfully grows many thousands of seedlings in this way. The plants must survive the transition from the sterile laboratory to the real world. When the orchids were mature enough, some were taken to a special growth chamber in the zoo's greenhouse. Sue Friedman is the greenhouse manager.
What we try to do is come up with a method that the students might be able to use in Madagascar to reintroduce the orchid seedlings that we've been growing here at the zoo. The acclimatization period outside the vessel for natural reintroduction is a very hard and difficult procedure. We take it to our growth chamber.
Many Malagasy orchid species attach their roots to trees rather than growing directly out of the soil. Creating successful field reintroduction methods took some experimenting, but Friedman had a valuable tool beyond the greenhouse to develop the best techniques.
We have this enormous teaching laboratory. We call it the Lead Jungle. It's 1.5 acres of rainforest under glass. For our research, we actually use the jungle as our laboratory for the reintroduction project.
Fidi, from a village near Rana Mafana National Park, conducts the orchid reintroduction in Madagascar. In December of 2003, Fidi came to the Henry Doherty Zoo for 2 months to work with the Omaha team.
He and I developed methods of mounting the orchids on branches, and we would actually take them out of the small tissue culture vessels and mount them on the branches and have them in the Lead Jungle, and did our monitoring and study work in the Lead Jungle.
The zoo's man-made jungle provides conditions similar to the actual rainforest. This allows researchers to determine the best methods for starting the young plants in their natural environment. In Madagascar, Fidi would have limited equipment. Through trial and error, the team determined what simple tools and supplies to use that would be available to Fidi in Madagascar. He would use these to implement the reintroduction. Armed with his new skills, Fidi returned to Madagascar. He was prepared for the first of several shipments of small plants from the Omaha Zoo. Upon their arrival, he began mounting them in the forest. GPS and map coordinates from the seed collection process allow him to reintroduce a new seedling near its mother plant. Everyone was impressed with the growth of the new plants.
they grow well, and I think that I will improve a lot this last time because I find out many things interesting with the reintroduction, and I find out also many problems with the work kids. So now I can manage it well actually.
I had really anticipated that success for us would be maybe 10 to 15% survival rate on our first reintroductions, and it's 35 to 65%.
It was much more productive right from the start than we had anticipated, so that was really exciting.
The team's success was a critical step for conservation. Reintroducing orchids from sterile test tubes directly back into the forest had never been successfully done before. This can dramatically increase the population of endangered species in the wild, and the genetic diversity of these plants is preserved for the future. One reason plant conservation is important around the world is potential medicinal applications. Nearly 40% of all medicines come from plants.
Less than 2% of the approximately 500,000 plant species on the face of the earth have been tested for their pharmaceutical value. There is enormous possibility out there to alleviate illnesses and benefit mankind.
One example is Madagascar's rosy periwinkle. It produces medicines that are now treating childhood cancers around the world. Scientists know there's much more research to be done. These exotic plants could contain important medicinal benefits.
And so much of the plants are still unknown. I mean, they're being destroyed before we even know what secondary chemicals are in there and what implications those have on global health.
The orchid research is just one aspect of the zoo's project that operates both in the wilds of Madagascar and in Omaha. The immense amount of information the team collects in Madagascar ends up in the zoo's Center for Conservation and Research. Here, all the data collected about the lemurs is processed, from physical characteristics to DNA samples to capture locations. Blood and tissue samples are analyzed with state-of-the-art genetic testing equipment. The information tracks the locations, movements, and numbers of various lemurs. The process can also validate the identification of new species. As with the fieldwork in Madagascar, students play important roles in the lab.
There's a unique aspect of this project that's actually very critical to its success, and that's the provision that's made for bringing Malagasy students to the Omaha Zoo's lab to complete their research.
It's really opportunity for me to hands-on molecular genetics in all its technologies, because in Madagascar we don't have no lab available for that kind of genetic stuff.
It gives them a chance to learn how to do the genotyping and how to do the sequencing, how to do the analysis, which is really important so that they can take that information, that knowledge, back to Madagascar.
This collaboration between the University of Antananarivo and the Omaha Zoo gives advantages for the students. First, helping them with their fieldwork. Second, they can learn to use high-tech equipment from the USA. Third, they get training at the lab at the Henry Dorley Zoo.
During their internships, the students collect samples, generate data, and analyze the data. They must publish their findings in what is called a first paper.
What we require them to do is not only collect the samples, they have generated their data, they have analyzed their data, and they're forced to write in a language that they're not used to to write their first author papers.
Publishing first paper is important for me to make people know what you've done about Madagascar, and it's also a big opportunity for me to write English and make people know you that you can do that research in the future.
We can't do any publication without partners, so this collaboration with the Henry Dorley Zoo is very helpful for us. This association is very important, not only for the students, but especially for the professors.
By having first author papers, they'll be able to have this on their CV or resume when they go ahead and apply for a grant, whether here in Madagascar or an international NGO granting agency. They will have the credentials to be able to obtain the money to operate a project on their own.
The enthusiasm of Malagasy students will be important in expanding conservation efforts in Madagascar.
When my education was completed, I want to extend the conservation project in Madagascar and to cover it on Madagascar also, and by sharing my knowledge and educating the Malagasy people to focus on the conservation.
I would like to contribute on Madagascar conservation, especially on biodiversity, and also I would like to educate future generations about how unique our biodiversity is.
Many governmental and non-governmental organizations, or NGOs, physically manage the protected areas of Madagascar. They also work to educate the people about conservation. Data from projects like the zoos help these organizations accomplish their missions. The main governmental agencies are ANGAP, the Malagasy acronym for the National Association for the Management of Protected Areas, and OEFORE, the Ministry of Water and Forest, which is similar to the U.S. Fish and Wildlife Service. ICTE is the Institute for Conservation of Tropical Environments in Madagascar. FANAMBI, which means challenge in Malagasy, is another NGO working with local communities to encourage conservation. FANAMBI has an active presence in the rural community of Dorena. There are some protected forests in the area, but vast amounts of land have been burned off for cattle grazing.
The biggest challenge that we have for those forests right now is the need for greater land. So slash and burn is growing and growing, and we have to control that and use those areas that we have outside the forest to work with the communities and protect the forest, and also develop those areas where we can do the agricultural development for the communities.
The organization teaches the people about alternatives to slash and burn agricultural practices. FANAMBI personnel are realistic about balancing the needs of the people with conservation efforts.
We're trying to help the communities plant new trees, fast-growing trees for the need that they have for the region and also outside the region. So we're trying to work with the communities and teaching them to do that.
In Dorena, FANAMBI has a Center for Conservation Activities and Community Education. The NGO fosters goodwill in the community by providing resources such as electricity for the local school. A computer lab gives children hands-on access to new technology and even offers internet access. The educational program for young people stresses the value of natural resources. Leaders hope that children of today will make conservation an everyday practice as they grow. Governmental agencies like ANGAP are also helping the local population. ANGAP officials manage national parks throughout Madagascar. The agency gives local residents direct financial benefits from conservation. 50% of national park entry fees go to the adjacent community. Historically, tourism and research were the only activities permitted in these preserves. Madagascar's recent pledge to triple protected areas is ambitious. The government realizes it needs help to oversee all of these areas. To address this, local communities are given greater access to protected areas in exchange for expanded conservation efforts. The goal is to attract more tourists. The plan also encourages the development of increased services for visitors, such as hotels and restaurants that are in harmony with the environment.
These are just ideas that will help the economy of this country and allow it to maintain the resources and the biodiversity that's in this country.
This concept is often called ecotourism, which is defined as responsible travel to natural areas that conserves the environment and improves the welfare of local people. Some view it as essential to the survival of Madagascar's endangered species and the future of the island and its people. Ecotourism creates many employment opportunities. Professional associations train Malagasys to become knowledgeable and paid guides. Hotels and restaurants cater to new visitors, creating more jobs. As tourist activity increases, sales of local crafts can provide more ways for people to make a living.
Ecotourism, it's going to be, I think, Madagascar's future. You look at other countries that have their gross national product, like Costa Rica. It could fund so much for just the ordinary person, whether it's having a restaurant or having a tourist shop or having a tourist company.
Ecotourism holds great promise for the future of Madagascar. But the endangered habitats must be saved to attract the tourists. The work of many organizations, including Omaha's Henry Doherty Zoo, hopes to ensure that the country's incredible biodiversity exists in the future.
Our challenge is to protect those areas, but in order to protect that, we need to understand the biodiversity that exists in those forests. And those programs that are headed by Ed Lewis help us understand the biodiversity and better figure out where the biodiversity is and put that under protections.
The important part is getting the Malagasy students the information and the technology transfer so they can be able to do this themselves.
We can teach you how to do this, and we can give you the methods and give you the data and give you the technology, but you have to have the passion.
It's essential that Madagascar have teams of trained and experienced professionals in order to preserve what remains of its natural biological heritage.
It's a privilege and it's an honor to have some role in seeing to it that these species don't disappear from the face of the earth.
Now it's up to Madagascar. But the tools, the technology, the training has all been given to them.
If I came back here in 20, 30 years from now and I can see the people that we trained in key positions and progressing and becoming important role models for their students, that would be the greatest thing. Also be able to come back and see sites that I visited this year or last year and see that they're still there and still being maintained, and best of all, that they're growing and that the infrastructure around them, whether it's hotels and tourism, is thriving. That would be the best benefit I would ever see that happened from all this work and effort.
On a bright morning in Madagascar, these school children assemble to greet visitors. They sing a song. It is a song about how the amazing lemurs and the beautiful forests are their country's gold, their own precious treasures. One child, one person at a time, the message of conservation is making a difference in this truly unique island paradise.
Major funding for this program was provided by the Theodore F. and Claire M. Hubbard Family Foundation, with additional support by From the Top, a national public radio program showcasing the musical talents of young people, and Huntel Communications Incorporated.